Hello, this is Coach Holmes, and today we're going to be talking about multiplication properties. So last time we actually talked about addition and subtracting properties in order to solve for equations. Today we're going to be doing the same thing, but this time we're going to do multiplication. But not just multiplication, but we're also going to learn how to divide, because the opposite of multiplying is divide. But we're also going to do a little bit with fractions too, because I do think that's important just as well. Not just be able to multiply and divide from both sides, but also multiply fractions on both sides. And we'll get to the fraction in a little bit. But first off, I want to talk about the definition of multiplication property. The definition is to multiply the, excuse me, this is a little bit funny. Multiply the same number to both sides of the, bet you that's my book, both sides of the equation where they remain equal. Okay, so going back off of the weightlifting or benching the bar. So imagine, if I have 10 pounds of both sides, okay, let's just go off of that. Let's say I want to double it. So I want to double the 10 to make it 20 pounds. So remember, what I do on one side, I got to do it to the other, because otherwise it's going to feel awkward. So if I double the weight on the right side, I'm going to double the weight on the left side. And again, I can't just say, well, I want to double one side and triple the other, because that's still going to make it a little bit awkward. So again, if I double on one side, I'm going to double the weight on the other. But I can also divide it by 2, or half the weight on one side, and I can half the weight on the other. Okay? So the application does work for both multiplication as well as division. But first, I want to go over examples where we have to multiply both sides. So look at this first example. I got x divided by -3 equals +4. Okay? Now, so one of the things I want to keep in mind is that there is a negative right here, but I can easily put the negative in front of the x. It does work out both ways, but I'm just going to leave it at -3 for right now. But when I solve for the variable, I want to make sure that I don't just have the variable by itself, but I want to make sure that it's positive. Okay? So when I multiply 3, I'm not just multiplying by +3, I'm multiplying by -3. So remember, what I do to one side, I gotta do it to the other. So I'm multiplying 4 by -3. Now, -3 divided by -3 cancels out to be 1. Okay? So this is the one time where when it cancels, it's just becoming 1. So they cancel out, and I'm left with x. Now, 4 times -3 is going to give me a -12, because remember, a positive times a negative is just going to give me a negative. Okay? So be aware of that. Now, I got m divided by 2 equals 4.1. So again, since this is division, and I should have mentioned this earlier, but the inverse of division is multiplication, because they're opposite of each other. The opposite of dividing is multiplying. Opposite of multiplying is dividing. So I want to take the inverse of m divided by 2 to both sides, which I'm just multiplying by 2 to both sides. 2 times 2 is 1, so that cancels out. And I'm left with m on the left side. 4.1 times 2 is going to give me 8.2. Since the m is by itself and it's positive, that's all I have to do. And that's my answer. So the answer for m divided by 2 equals 4.1 is m equals 8.2. So remember, since they're dividing to each other, I gotta do the opposite, which is just multiplying. Now, let's look at some samples where we have to divide instead. We have to divide both numbers on both. We have to divide numbers, the same number on both sides. So I got 5 times x equals negative 25. So remember, if these two numbers are close together like that, there's nothing in between them. There's nothing in between them. That's not a positive. That's not a negative sign. But they're back to back like that with the coefficient and the x, not just a negative 25, because that's just a number. But if I have a coefficient and a variable back to back like that, they're multiplying. So I want to divide 5 to both sides because the inverse of multiplying is dividing. So 5 divided by 5 becomes 1, so that cancels out. And I get x equals negative 25 divided by 5 gives me negative 5. Kind of like how we said earlier that a positive number times a negative number will give me another negative number. Dividing works the same way. A negative number divided by a positive number still gives me a negative number. And it doesn't matter which number is positive or negative as far as the order. Next, I'm going to have negative 3 times y equals negative 42. So remember, I got to get rid of this negative 3 somehow. The inverse operation for multiplying, since they're multiplying to each other, is dividing. So I'm going to divide negative 3 to both sides. So this cancels out, and I'm left with y. And even with the negative, negative divided by negative is positive, which, by the way, just happens to be what we have. If you have a negative times a negative, that gives you a positive. Division works the same way. If you have a negative divided by a negative, they become positive. So, negative 42 divided by negative 3 will give me a positive 13. So the answer for this is y equals 13. Now, I know I'm forgetting to fill in the box. Okay? But the answer for negative 3 times y equals negative 42 gives me y equals 13. Now, I do believe that it's important to know how to work with fractions in this sort of way. But it's a really simple idea, okay? So, 2 over 3 times x equals 10. Okay? Now, how can I get rid of that? Well, what you could do is what we call reciprocal. I'm going to take the reciprocal of this fraction, which means is that I'm going to flip the fraction and multiply. So for example, if I have 2 over 3, I'm going to flip it to where it's 3 over 2. Just like how I have it now. Now, you could multiply across to say 3 times 2 is 6, 2 times 3 is 6, 6 divided by 6 is 0. 6 divided by 6 is 1, not 0. My fault. Or you can just simply say, well, 3 cancels out 3, 2 cancels out 2. They both end up being 1. And that works out the same way. It doesn't matter how you look at it. They both work out the same way. One benefit about math. But remember, when I do to one side, I gotta do it to the other. So since these cancel out, I have x on the left side. Now, what you could do here is you can put a 1 underneath the 10 and say 10 times 3 is 30. 1 times 2 is 2. Well, 30 divided by 2 is just simply 15. So the answer for 2/3 x equals 10 is going to be x equals 15. Okay? So this happens to work out to where there's going to be a whole number. You may end up getting fractions, but that's okay. Just leave it as a fraction, leave it how it is, unless you can simplify from that fraction. Now, -1/4 times y equals +3. So again, I want to take the reciprocal of this fraction. So remember, it's 1 on top, 4 on the bottom. So if I take the reciprocal of it, I want to switch or flip the fraction itself. So if I'm switching it, I got the 4 on top and the -1 on the bottom. But remember, when I do to one side, I'm doing it to the other. I'm going to put a 1 underneath the 3 for in a minute. Now, 4 cancels out, -1 cancels out, so that leaves me with y. Now I'm putting the 1 underneath, so that way when I multiply across, I'm getting 3 times 4, which is 12. 1 times -1, which is -1. Now remember, just because there's a -1 underneath, like this, doesn't mean that that this whole number is just a +12. Because 12 divided by -1 is still -12. So the answer for -1/4y times y equals 3 is y equals -12. So that's the last sample we have. But again, just like addition and subtraction, we still got to work the inverse operation for multiplying and dividing. Now, the biggest thing we do got to keep in mind, though, is that when we take the fraction of it, we want to do the reciprocal of it, of that fraction, and use that reciprocal to multiply both sides. But again, I'm still multiplying. Because in this problem right here, 2/3 times x equals 10, the reciprocal is 3/2. Which means I'm multiplying both sides by 3/2, not 2/3, or any other number. So just keep in mind that the operation is very similar to addition and subtraction, but we are working with different operations. But the principle and the idea is the same, that what you do, not only what you do on one side, you do to the other, but you do it by the same amount and by the same number. Okay? So just be aware of that. Whatever you do to one side, you do to the other by the same number. Thank you. Have a good day.